Hello guys, welcome back. I'm Chava the scientist, your favorite chemistry tutor. If I'm not here at your favorite, you must relax because you are still going to like me. I'm going to be with you through this critical corona time to make sure that you stay in line with your chemistry, you don't lose the chemistry. So instead of going out there gallivanting on the streets, it's very important that you stay with me, because you go out there, you end up finding yourself with this deadly coronavirus. So today we are continuing from where we left off yesterday, where we're doing organic chemistry, naming of compounds, right? So as you can see here, I've got an example that I want us to do today, and I've got even more examples that we'll be doing to just put this concept of naming in our heads, right? As you can see here on my left hand, I've got a prefix, root, and a suffix. This table is very important to keep it in your mind in your example, because they don't give you such tables. So it's very important that you know these things. They stay with you. If you do more examples, this table will just go automatically into your head, right? So yeah, it's very important to know this table. We are trying to name this compound, right? Remember what I said yesterday, that organic compounds, they compose of a prefix, root, and a suffix. Together you can be able to choose the name, right? So if you want the name of this big compound here, the first thing that we need to do is to identify the longest chain of carbons, right? So let's count to identify the longest chain. 1, 2, 3, 4, 5, 6, right? So that is it looks long. 1, 2, 3, 4, 5, 6. That looks long. 1, 2, 3, 4, 5, 6, right? So now, for us to count, remember we said we must count from the side which is closest to the substituent. So if you start this side 1, 2, 3, you see the substituent is on carbon number 3. While if you start this side 1, 2, so the substituent is on carbon number 2. So you can say 1 on carbon number 2 we have got a substituent. So it doesn't matter even if you start here 1, 2, right? On carbon number 2 we have got a substituent which is having one carbon chain, right? So it's 1, 2, 3, 4, right? When you get to number 4, if you go this direction, you still have a branch of 2 carbons. If you go this direction, you still have a branch of 2 carbons. So no matter which direction you go, it's fine. It doesn't matter because you have got the same branch. So if you go here, this will be 5 and then 6, right? So that means if you go this direction, the other one will be our branch. So this part here is our branch, and then we've got another branch here. So we have got 2 branches. So now we need to go to the naming, right? If it's 6, that means we have got our roots, because we have calculated the longest chain of carbons. 1, 2, 3, 4, 5, 6. So if it's 6, it's hex. That means our root name is hex. So we have got 6, right? Let me use a different color so that you can be able to distinguish here. We have got root. You have got root is hex, right? And then we go to our suffix, right? For our suffix, we just check what functional group is this compound, right? We need to know which functional group is this compound, right? So we check at the position of the branches and all the things. Right now, if you can see here, you've got single bonds. Your compound is only made of single bonds, so you don't see any double bonds. That means this cannot be an alkane, because an alkene has got double bonds. Alkyne has got triple bonds, right? So we go here, that means this is an alkane because it's made up of single bonds. So we are expecting it to end with the suffix ane. So we go here, our suffix is ane, and then now we go to our prefix. Well, I like to end with the prefix, but actually the prefix, it's where you start off with your name, because you start with the prefix, root, and then a suffix. Together they give you your name, right? So with our prefix now, prefix will tell us the position of the branches. So we go now, we say 1 on carbon number 2, we've got a branch, right? That particular branch here what type of branch. If we want to name branches, remember we said now because this branch now is a substituent, right, we need to add YL. So a prefix here is YL because it's now this branch is composed of only one carbon. We said here on my table, go to my table, if it's 1, that means it's a methyl, 2 ethyl, 3 propyl, etc. So now this is a methyl, right? So we have got on carbon number 2 we have got a methyl, right? We're just writing them randomly. We have got methyl, right? And then we go again on carbon number 4, we have got a branch of how many carbons? There are 2. When it's 2, we say it's a what? Ethyl. So you have got 4 dash ethyl. Now it's time to put our name together, right? Remember we said name is prefix, root and suffix. So we start off with the prefix. Now we see our prefix. In this case we've got 2 parts of our prefix here. We've got the methyl and the ethyl. So for us to put this thing together, remember we said you put them alphabetically. You see, as you can see here, 1, 2. On number 2 we have got the methyl, but we are not going to start with the methyl because M comes after E. You see, it's A, B, C, D, E, right? And then M comes after. So we are going to start with the ethyl, no matter its position, but it comes first alphabetical. So we have got 4 dash ethyl dash 2 dash methyl. Then we come, this is our prefix. Now we go to suffix, to the root, right? It's methyl. We said our root is what? Hex. So it's hex, right? And our suffix is ane. So our name is 4 ethyl dash 2 dash methyl hexane. You see, so this name is made up of as you can see here, this part, it's our prefix, then we've got the root, and then this part here is our suffix. So it's very important that you get this thing in your mind so that you can be able to name organic compound. So now we can try another example that I picked today. Let's try another example. Another one that I picked here, I've got this one will be the second example. Let me use black just to write my example. Number 2 here, I've got C H C H double bond C. Don't forget carbon must have always 4 bonds. So it's H and then C 1 2 3 4, right? That's good. And then we've got H. Yeah. Now look at this particular compound. So I want to just shift this bond. Firstly, we'll come back to this one, but I want us to note something here. Let's say the bond here, it's on the first carbon, right? Now first thing we do, identify the longest chain that will give us the root. The longest chain is 1 2 3 4 5, right? So remember I said when you are numbering, you need to start off numbering from the side which is closest to the functional group. You cannot start this side, right? You'll know in a minute why am I saying that, because it's very important that you number according to the rules, right? So now let's try to name this compound, right? So we see here, first thing, we know the root now because it's 1 2 3 4 5. So when it's 5 is what? Our root is penned. So root is so our root is penned, right? And then our suffix what is our suffix is because we see here we need to identify the functional group. Now we see that no, this is an alkene because we see a double bond, right? But we do have single bonds, right? But because we have a double bond now. This is going to be an alkene because the double bond will supersede the single bond. So it takes priority over the single bonds, right? So this is going to be an alkene. So our suffix, we expect this name to end with in. So our suffix is in, right? So one thing that we need is a prefix, but in this case we don't have any substituent, so we don't mind this thing of the prefix because all our hydrogens are not substituted, right? So we can come with the name. Now we add these things together, we come up with the name pentene, right? Now someone will say, no, what if I write because you said you must indicate position. You see, you must always indicate the position of our double bond, right? And then someone comes and say 1 pent in, right? 1 pent in. So now who is correct, who is wrong, right? So 1 pent in, this one is very correct because naturally this name needs to be 1 pent in, right? But now because it's position 1, so it's position 1, so it does, if it's on position 1, it's not necessary that you write the 1. You can even write it as pentene. So both the names are correct. 1 pentene and 1 and pentene, they are correct. But now suppose now we decide to say no. Let's say now we shift the double bond now. Let's say we shift the double bond now, it's here, right? Now we have something like this. Remember, we cannot number from this side to say 1, 2, 3, right? We need to start from this side because it's closest. It's closest. If you start this side, you'll get faster than starting this side. So it's 1, 2, right? So we try again. It's a chain consisting of, the longest chain is consisting of 1, 2, 3, 4, 5 carbons. So we have got our root. The root is pent, right? And then we have got our suffix is still in, right? It's still in because we have got a double bond. Now what is the difference between this compound and the first one? Because it's the same compound, I just changed the location of the bond, right? It was here, now I change it to this location. Now where is the difference? That's why it's very important to illustrate the location of your double bond, because those two, they are different compounds. They are not the same. They are different compounds. So it's very important to illustrate the position. In this case, when naming such, you are going to say no, because I see my double bond is on the second carbon. So you are going to say 2 dash pent in. You see? So you are indicating with these two, you are indicating that no, my double bond is on the second carbon, right? Someone can be like, okay, I want to write it like this: pent dash 2 dash in, right? Both names are correct because the 2 indicates the position, right? Whether you write it this way, you like it that way, or this way, both of the names, they are correct, right? So now let's jump into some more examples. So yesterday we were just doing hydrocarbons, which are compounds that consist of only hydrogen and carbon atoms only. So today I decided to say no, let me come up with something new. So today I added something. So I decided to say no, let me add alcohols. The most famous functional group that many people like, right? Alcohol, the one that people drink. We see it with OH. So you must never get alcohol wrong. Because many people like alcohol, so you know they like OH, right? You see an alcohol with OH, so they've got OH to indicate that no, this one is an alcohol. So let's try here. I've got an alcohol that I placed here. We've got H, H, then O, H, right? So look at this. This is an alcohol, right? Because we see what? We see that OH, this thing tells us no, this is an alcohol, right? Now where is the difference if we start here and say COH, then we go now where is the difference? Where is the difference? We have this and then we have that. Where is the difference? Because they both have OH on their first carbon. So remember, we start numbering from the side which is closest to the functional group, or in the case of alkanes, you start numbering from the side which is closest to the first substituent, right? So now let's see, we want to number here. We're not going to start this side, we'll start this side. I'll show you why. So 1, 2, 3, 4, right? And then someone says, no, you started this side. 1, 2, 3, 4. No, you cannot go in that direction, because in this case the substituent is here, so you need to start here. 1, 2, 3, 4, right? So it will tell you that these two, they are the same. They are the same. There's no difference between the two, right? So now we have it like this. On my table here, I decided to add alcohol under the suffixes. You can see alcohol, they end with all. You see, when you have an alcohol at the end, you'll have OL, all, right? Now let's try to name this one. We identify the longest chain, 1, 2, 3, 4, right? So the longest chain is 4. That means if we have got 4, it's but, right? It's but, so it means 4. That means our root is what? But. It means 4. Now with but in our mind, but, you said but means 4, right? So we have got our root, it's but, root is but, right? We also have we don't have substituent, so we don't have the prefix, right? So our root is but, and then our suffix is all, right? Now someone will come, okay, you have got your butane all, that means this is butol. No, guys, when it's an alcohol, the root now changes, guys. So for alcohols, from alcohols it changes now. It's no longer, the root is no longer meth, but for alcohol it's an. You add an here on your root. Ethan, you add an for alcohol. Propan, butan, pentan. You see, going forward, you see. So for now we have got root to be butan, guys. So you must always remember, for alcohol you must add that an. So to put our name together for this particular alcohol, we say it's butanol, right? The same story happens for alcohol, because you need to locate where is your functional group located, right? If you go like it's 1-butanol, that is very correct, you see. But for, remember, when it's on the first carbon, it's not always a must for you to write 1-butanol. You can even say it's butanol, it's fine. For someone who knows chemistry, tell you no, butanol, it means that your alcohol is on carbon number 1, right? But it's not necessary if it's on the first carbon, right? But it's necessary if it's not on the first carbon. You must always write like so the correct names here is butanol, that's a correct name. And then someone can be like butanol without the location, butanol without the location of the substituent. This is also correct. And then someone will come and say butan dash 1 dash all. So all the three names, they are correct. They mean the same thing. So let's try another one. Let me remove everything here, and then this one will be our last example of an alcohol. Just to, let's say I've got C H C O H, then you've got H C H H C H H H, right? And then you identify the longest chain. The longest chain, you start from the side which is closest to the substituent, right? For in this case, the functional group, not the substituent, because we don't have any substituent. So you go 1 2 3 4, not the other way around. 1 2 3. So the OH is very fast. So you start this side 1 2 3 4, right? So now we need to deduce the name. You said, oh, okay, you said the root for such, when it's an alcohol, you go, the root is butan. The root is butan, right? And then I said, okay, no, when it's an alcohol, the suffix is OL, so that means it ends with OL, right? So does this mean that our name is butanol? No, the name is not butanol, you see, because we had that one with the OH at the beginning. So you mean those two compounds, they are the same? No, they are not the same, guys. They are not the same. Such compounds, we call them isomers. But I'll give more details on isomers. Right now, it's very important to differentiate, because we are dealing with naming right now, but it's very important to differentiate those compounds, right? Because now the alcohol is on number 2. That's why I'm saying it's very important to locate your functional group. So in this case, you've got the alcohol on number 2, right? So you need to say, no, this is on number 2, so it's 2-butanol. 2-butanol, that's the correct name. Or you can go like butan -2-ol. Thank you very much, guys. Thank you very much for watching this video. I hope I'm your favorite now. If still I'm not your favorite, it's fine. It's fine. You are going to like me, because I'm coming back with more and more amazing content. So you stay tuned, stay at home, protect yourself from this coronavirus. Thank you very much. See you on the next video.